Morning. We today are going to work with the distance formula, as it says right here on the screen. We're going to try to find the distance between 2 points. So you might be going, hey, great, when am I ever going to, somebody ever going to give me a coordinate grid and say, hey, can you find the distance between 2 points? Well, obviously in this class we're going to ask you to do that, but if you have a GPS in your car, and the GPS constantly updates you how far you are from certain places and how long it's going to take you, they're using something like the distance formula with longitude and latitude and coordinates to find how far things are, and then based on your speed, it recalculates how long it's going to take you to get there. So, this is pretty simple, a simple version of it, but let's work through it. Finding the distance between 2 points. So, the first point is 2, 3, and remember we go x, y, just as a refresher. So there's roughly 2, 3. 7, 8 is about there. Okay. Make sure, of course, that you do watch the entire video, because at some point at the end I'm going to ask you a question that you'll want to be able to answer so that you can verify that you did really watch the whole video. So we're looking for the distance between these 2 points. So basically we're looking for the length of, I will do my very best, length of that line roughly. How long is that line? Okay, so with that in mind, I'm going to write my coordinates down here, 2, 3, 7, 8. Okay. So no straight way to get that information. What I could do though is I can put an extra point right there, okay, right there at the corner, and that extra point at the corner, its coordinates, it's going to have. Let's see if we can figure out its coordinates. Its coordinates look like to be about 7, 3. Okay, so it's got the same y coordinate or the same x coordinate as this one, and the same y coordinate as that point. Okay. Could we figure out how long this side length is right here? So we can certainly tell the length of this side. Length of this side, we're going from 2 to 7, so 7 minus 2, that side's 5. Okay. This side right here, well, we're from 8 down to 3. That looks like that's 5 also. Okay. Notice what we've made is we've made a right triangle. We all know if we have 2 sides of a right triangle, we can use the Pythagorean theorem to get the third side. So essentially what we've got is 5 squared plus 5 squared equals, well, we'll call that c squared. 5 squared is 25, 5 squared is still 25, 25 plus 25 is 50. That's what c squared is. So c is equal to the square root of 50. Which we could use the calculator if we wanted to get that number. It's a little more than 7, but for our purposes, square root of 50 is a fine answer unless it's one of the ones that we know 1, 4, 9, 16 or whatnot. We can just leave it as the square root of 50. So this side is the square root of 50. The distance is the square root of 50. If we were talking about miles, it'd be a little over 7 miles. 7.1 or something like that, probably 7.0 something actually. All right, so the distance formula. That's how it works. It's based on the Pythagorean theorem. We probably want to be a little more sophisticated. That's what we'll do on this next slide, is be more sophisticated. Okay? Generally speaking, I should be able to put a point anywhere on the coordinate grid. And I'm just going to call this point at random x1, y1. And I'll pop another point up here, and we'll call that x2, y2, just like we used to do when we were calculating the slopes of lines. Okay? So let's pop that corner point in. Let's do it in red this time. Okay, there's my corner point. Okay, its coordinates. Let's see, it's got the same x coordinate as this one, and it's got the same y coordinate as that one. True? Okay, so its x coordinate matches up. It's, if we're using numbers, it's both are at 2 and they're both at negative 3. Drawing in the sides of my triangle. Okay. How am I going to get the length of this side? Well, this side is just the difference between my 2 y coordinates. Okay. This side is the difference between my 2 x coordinates. Right? x2 minus x1 is what that says. If I want to find the length of this side, I would square this, square that, add them together, take the square root. Okay? Turns out that, oops, I had it, I lost it, there it is. It's the distance formula. The distance formula. Okay? So the distance formula, it's a lovely formula. There it is. Okay? For your viewing pleasure. We're just taking the coordinates, x2 minus x1, squaring them, y2 minus y1, squaring them, taking the square root. It's the Pythagorean theorem. Okay? So all we're looking at is the Pythagorean theorem, slightly adjusted for a really specific application. But you remember the Pythagorean theorem, and I'm sure you do, you can always get to this without actually having to memorize the distance formula. Okay? We'll work a couple of problems, and really it'd be about 3 problems, so stick with us for all of them. And again, want you to watch the whole video because the problems get a little more complicated as we go. Sheet and pop the distance formula down here. There it is. Okay, so that we can use it. And I would recommend when you're doing these, at least the first, 75 problems that you do with a distance formula, you write it down, and it makes it easier. Okay, so we're trying to find the distance between 4, 7, 8, 2. Here's x1 and y1. That's an x. There's x2 and y2. Okay, it doesn't matter which one you label. You want to call this x2, y2. It doesn't make a difference. The numbers don't know where they're written on the board. You're going to get rid of the red pen, go to a blue pen. Now that we've got all those, it's just a matter of plugging them into the little formula. Distance is the square root of x2, which is 8, minus x1, which is 4, squared, plus y2, which is 2, minus y1, which is 7, squared. Okay? 8 minus 4, 2 minus 7, great. 8 minus 4 is 4, 4 squared. 2 minus 7 is negative 5 squared. And we're going to take the square root of that. 4 squared is 16. 5 squared is negative 5 squared is 25. Remember, when we square a negative number, we always get a positive number. That's why I put it in parentheses to make sure. The calculator sometimes will, if you do this with the calculator, it'll give you a negative. We don't want that. We want with parentheses. 16 and 25 is 41. Square root of 41, if I was a guessing man, would say it'd be about 6 point. Let's go 4. 6.4-ish. I'm going to put approximate because somebody's going to push the calculator and go, hey, Mr. K, you were wrong. Now, square root of 41 is somewhere bigger than 36, which is 6, less than 49, closer to 36 than 40. It might be 6.5. We could grab the calculator, but we're not going to worry about it. Okay, so process. You have a formula, you have some coordinates, you label them, you plug them in, you turn the handle, you spit out an answer, you go. Okay, so, again, distance formula, the lazy man's way. There it is. Same story. x1, y1. This takes an extra 14 seconds to write down those coordinates so that you have them so you can just plug in. I recommend it highly. Distance, square root, x2 is 8, minus x1, which is 5. Square those. Plus y2, which is negative 7, minus negative 3, squared. Okay? So, we work through there. 8 minus 5 is 3. 3 squared. Negative 7 minus negative 3. And pick this example just to make sure that we're clear on this. Remember the double negatives like plus? So we're really looking at negative 7 plus 3. 7 below 0, 3 degrees colder. It's negative 4 now. Squared. Right? Take the square root of all of that nonsense. There it is. 3 squared is 9. 4 squared is 16. Okay, 9 plus 16 is 25. What's the square root of 25? It's 5. Okay, there we go. Simple as that. Okay, so here's what we're going to do. We're going to go to the last problem. It's the last problem. Yeah, it's the last problem. I'm going to put the distance formula down on the screen. I'm going to ask you to pause the video for just a brief moment and work your way through this problem. Okay? I'll be waiting for you. All right, did you pause? All right, and you have an answer, I'm sure. Okay, so Probably while you were paused, I should have done this, but I didn't, so we'll just walk our way through to make sure that everybody's good, or if you got stuck, you can see what you're up to. Oops, there you go. That's a 1, right? X1, Y1, X2, Y2. Wouldn't be a video if I did not make at least one mistake, so I can pretend that I did it on purpose. X1, but at least I caught it before I went too far along in this process. All right, so distance. Plug in, that's what I'm doing, isn't it? Yeah, X2 is -6 minus 5 squared plus -12 minus -8. Holy cow, negatives all over the place. Squared, square root of all of that stuff. Okay, so here's where it becomes difficult. -6 minus 5 more. Hopefully you recognize that that's -11. Okay, -12 minus -8, that's like -12 plus 8. That, I believe, is -4 squared. All right, so now here's where it gets difficult. 11 squared is 121. 4 squared, just like last time, is 16. Square root, 137. How's that sound? Okay, so decimally wise, that's going to be, well, 144 is 12, so it's going to be less than 12. And so how close? I don't know. If I was guessing, 11.8-ish maybe. That would be my guess as I was working my way through there. Okay? So, did you get that one? If you did, well, good for you. Good for you. Yay. So formula. Solve the distance formula. Help you find the distance between 2 points. Ties into GPS, ties into all that global positioning things. So, not that hard to do. Come into class tomorrow with questions if you have them, and be prepared to do a bunch of problems so that we can demonstrate that you know what's going on. Hey, thanks for watching, and oh, the question is, did you watch the whole video? I hope so. Thanks. Hope you learned something.